Finding lengths, intro, pretty much another way to talk about finding the distance. These segments here and this, you're just being asked to create a segment that's greater than 1 unit. So where I see students trip up is that they'll count how many dots there are and claim that this is going to be 2 units. But that sounds insane. This is just 1 unit that's measured here. However, if we were to move this line from here to here, this is now, count them, 2 units. But if it's just from one dot to the other dot, that's just 1 unit. So don't count the dots, count the spaces in between. 1 here, 1 here, 1 and 1 is 2. Last time I checked. So that's how this section kicks off. Just getting familiar with that. As we jump to computing, this first one, this red line has, count them, 1, 2, 3, 4 units to it. This blue line has 1, 2, 3 units, which is greater. 4, 3. Hopefully you're saying 4. So red has definitely got more to it. Red's a longer segment. Let's keep this going. We're now given vertical red line, which let's count as 1, 2 units. But what do you think about, or sorry, flipped. Red is 2 units. What do you think about blue? I'll tell you right now that blue is definitely longer. You could say something to the effect of how blue is on a diagonal. That's good for now. We'll see on the next slide that we have to be a little bit more crafty. So with our lines here, these are both on diagonals. They're not horizontal, they're not vertical. So we're kind of stuck. But luckily, we can use this old trick. A squared plus B squared equals C squared, or if that rings a bell, as Pythagorean Theorem. That's what we can use here. This allows us to take sides of a right triangle, so 90 degrees here. Again, this is called a right triangle. We can then have side lengths of A and B and a hypotenuse of C. So C is called our hypotenuse. There's a funny Key and Peele segment on this if you want to watch it on YouTube. But C is our longest side. So Pythagorean theorem allows us to square this side, add the 2 together, and that should equal our hypotenuse being squared. So let's talk about the red line. Not to be confused with the energy drink, a red line. We could make a right triangle, just like this. Right angles here. We can count our side lengths of 3 for this, 3 for this. We're still aiming to get that red segment, but we're now able to say that if we take 3 squared, this 3, and add on this 3 squared, this should equal our hypotenuse being squared. So 3 squared is 9. So this is saying that 18 is equal to C squared. But have we really solved for what the length of the red line is? The red segment. We got to take square roots. So now we're able to say that square root of 18 is the length of that red segment, okay? Capiche? Sound good? Take a moment, try to get a hold of blue, that blue segment. Pause the video, try this out. You could have gotten to some work like this with this length here of 1, this height here of 4. If you square 1 and 4, that should equal C squared. Now talking about this blue length. 1 times 1 is 1, 4 times 4 squared is 16. 1 plus 16 gets you 17. If we take the square root of both sides, this is saying that the blue line is now square root of 17 units. So which of these is greater? Square root of 18 or square root of 17? What do you think? Hopefully you're saying that square root of 18 is greater. So we want to make a note that the red line in this case is actually longer. So there you go. We even showed why. This is all leading up again to using Pythagorean Theorem, a squared plus b squared equals c squared. Write this at the top of your paper or whenever you're working on problems like this. It comes back again and again. Remember it. We're now given the option here to solve a word problem, nothing we can't handle. I'm going to highlight what's important. Well, what do you think is important? Maybe take a moment, pause the video, try reading through this. What do you think is important here? So we have the bottom of the red ladder, which is 3 feet away from the wall. So that means right here, this is 3 units. Our goal is to reach the window W up here, which is 7 feet above the ground. Does this look like a right triangle to you? I reckon so. So we have to square both sides, and this should equal our hypotenuse being squared. Let's compute this. 3 times 3 is 9. Add on 7 squared, which is 49. This equals c squared. We can now take the square root of all of this. So this eventually kicks back that the square root of 58 equals c. And if you use a calculator, I think this is what, 7.6 units approximately, or in this case, 7.6 feet. Luckily, Desmos will tell you if you're on the right track or not, so use this to help you out. Lo and behold, we got it. I showed the work here. Let's keep it going. Take a moment, pause the video, read through this, try it on your own. Your work could have looked something like this. You're going 8 miles north, 10 miles east. You're trying to fly this way as the crow flies is considered the most direct path. So you're really just working with a triangle that has a side of 8, a side of 10. Square both of them, add them together, take the square root of both sides. I'll leave you to find what this decimal is and type it in here. Capiche? Sound good? Let's keep it going. Same song and dance, but slightly different now, because now we know that from the home to mall, that's 10 units. We're also expected to go 6 units north. So really, we're working with a triangle now that only has a little bit for us of the hypotenuse is 10. That's given. We've been trying to get that this whole time. But now we're being asked to find how many units west we were heading. So let's work backwards a little bit. We know that if we take C6 squared and we add on the west unit squared, that should equal 10 squared. 6 squared is 36 plus W squared. This equals 100. We can deduct 36 from both sides. We're now claiming that the west squared is equal to 64. We can take a square root. We can now say that W equals 8 miles. Just like the M&M movie. We can hop back here. 8 miles. If you're really savvy, you could have just counted off that this is even 1, 2, 3, 4, 5, 6, 7, 8 units. But Pythagorean Theorem is something you should have tried here. You're now being asked if this 40-foot ladder is going to map out to the top of this building. That's why there's a question mark there. So let's imagine that if we redraw it, the ladder's 20 units away and the building's 38 feet high. So if this ladder was going to go all the way to the top, if it's 40, that's good. But if it's more than 40, that's no good. So if we take 20 squared, we add on 38 squared, this should be equal to our hypotenuse being squared. Do a little bit of arithmetic here, pause the video, try to get these numbers and take it further. If you did this correctly, this is claiming that the hypotenuse is approximately 42.94 feet, which means that 40 is not going to work. The ladder will not reach the roof because the actual, the ladder actually has to be 42.94 if it's going to keep in these dimensions to make that happen. So the ladder's not going to reach. Hopefully after this, you're a rock star and you can do this on your own. Hope that this video was helpful. If you got any questions, say something, let me know. Thanks for watching.